Hey everyone, I am going to demonstrate a really cool little programming concept. It's sort of a trick, a strategy, and to make loops and lists a lot better. And by better, I mean, look at my notes here, by better I mean easier to maintain, less buggy, and then in some cases faster and less memory. And a fourth benefit is that your code looks more professional because this is the trend. This is how people are coding right now. And so what I'm talking about is using a functional style of programming for changing lists and creating new lists. And in Python, we do that with list comprehensions. And so I'm going to get started here with a sample list that we might have in an app. And what this list is say this is a list of dog ages. Like I'm imagining that the app is for, say, a dog daycare, something like that. And let's just see here. I should be able to run this. Yes, there's our list of ages of dogs. And then, like what always happens when you write an app, we have things in one list that we want to then put in a different form. Maybe we want to reformat the string. Maybe we want to do some math on the numbers that are in there. And in this case, for the example, I want to transform this into a new list with the ages in dog years. And if you're not familiar, dog years are human years times 7. So here we go. And what I'm going to start off with here is what I'm going to call, in an opinionated style, I'm going to say, this is the old bad way that I programmed in for years and years. And I'm sure everyone else here has written code that looks like this. It's not so bad. But let's take a look and run this. Great. We get a second list with every number multiplied by 7. And how did we do that? Well, we create our new list. We start off empty. Good, has a known state, right? That's cool. And then we got to set up a loop. We loop through the original. We can see, so this age goes one by one through this list. We grab an age out of dogs. Here I'm doing the math. This new math is age times 7. And now that we have the dog year equivalent of the age, can add it to this new list. And then finally our new list is done. And one thing I'm seeing is that, sure, this could be shortened down to 3 lines, right? Instead of 1, 2, 3, 4. Yeah, instead of 4. By putting these together, don't strictly need this intermediate variable dog year. But I would maybe write it like this just to sort of document what is the age times 7. So something about, describing what that is. But anyhow, and that works. Well, I'm going to now demonstrate the exact same thing, but in one line of code. So first, let me just run it so we can see that it delivers on its promise, and it does. We get a nice second list, the same exact numbers, every number in the first list times 7. And so what is going on here? How is it possible to do the same thing that I have in 4 in one line? Well, it's a built-in feature of Python called a list comprehension. And the idea is we are describing what we want our new list to look like. And we start off by using the list constructors here, the brackets. So it looks like a list, what we're creating. It's a nice syntax. And then we say, well, we want the list, what should every element look like? Or what should each element look like? Any particular element should be the old item times 7. And so where do we get that old item from? Well, here it's for item in dogs. So it's the same kind of for syntax we're used to. So hopefully one of the things that's clear with this, one of the benefits that I see is that this is really, it's declarative, as we say. We're declaring what we want the result to look like, as opposed to telling the computer how to do it. And that's kind of always nice. If it works, if it's just as reliable as this old style procedural code, we'd call this, then declarative is always a little nicer. It's the level at which we're thinking. We want a new list that looks like this. And so there's some cool benefits that I've found in my code, and I think most people agree happens. One of which, well, since we only have one line in the place of 3 or 4 or 5, there's just one line where bugs can occur, one opportunity for me to make mistakes somewhere in here, or multiple in the one place, but one place to look for. As opposed to here, if you have a lot more code, then there's more opportunity for bugs and errors. And that's kind of what turns out to be the case in the real world. Another interesting thing here is that we're doing something that sometimes we're doing this thing called mutation that people tend to think can lead to problems. It makes code complex. We create an empty list, a new one, explicitly, and then we're going through and we're changing it in every loop. Change. We have to kind of make sure that our loop is changing it in the right way, etc., etc., etc. Here, in contrast, in the list comprehension, we're not changing anything. We're describing where does our data come from, and then we're describing what does the new data look like, each item. And we're not explicitly setting up this new list and then grabbing the final one. We're just handed it by Python, which is pretty cool. Another interesting advantage between these two is that they have different scopes and scoping rules. And so that's a technical term for a very easy concept, and I'll just demonstrate it here. So what would happen in this case if I say print age, if I include age in the output? What would we get? Well, let's take a look. We get this number 11, which, why is it 11? Well, it's kind of a meaningless number as far as the app is concerned. First of all, that's concerning because we didn't want the number 11 in particular. In age, it's sort of, well, it's random. It just happens to be the last element of our list. It's not meaningful anymore. It was only meaningful inside this loop, but we still have it floating around in the scope of all this code. And definitely having extra variables floating around that aren't useful anymore is a way for problems or bugs to pop in. If we try to do the same thing here, though, we'll see that we don't get that problem. And actually, this is cool, the IDE, I'm using Visual Code with the Python extension, the IDE is smart enough to now recognize and help us out. We get now help from our tools. This is undefined. I don't know what this item is. And if we try to run this, we'll see the equivalent. We get an error. Name items not defined. And so the reason is that what's common in this functional style is that we have a little scope within this description. And that this item here, it's more just like a descriptor. It's not a variable, this intermediate variable that's set and that we can continue to use outside of it. So it keeps things nice and clean and tidy, which kind of gives me a nice feeling. It's like cleaning up my office. Everything's in its place, unless like the trip, right? Which is maybe the equivalent of a software bug. And less likely to trip over some variable or data hanging out that did not want. And then finally, let's see here. Well, finally, there are some interesting optimizations that can happen with more advanced uses of the comprehensions in Python. And to get into that, I'll leave that for the next conversation. Okay, have a great night, everybody.